First of all, I would like to thank Professor Miyazawa and ICN Tokyo Organizing Committee for inviting me to speak in this symposium. Today, I would like to talk about chlorella protein digestibility and physiological function, especially beneficial effects of chlorella on dermatitis. Okay, let's start. We have no conflict of interest to report about this presentation. Introduction. Chlorella is one of the freshwater microalgae, and Chlorella vulgaris, one of the major species in Chlorella, are produced by over 70 companies in the world. Chlorella has a possibility to be a novel alternative protein source because it has a foodstuff with high protein content and can be industrial produced with culture tanks. However, there is a big problem to use chlorella as a protein source because chlorella has a rigid cell wall to prevent to use beneficial components in the cells. In this presentation, we attempt to clarify that chlorella can be an alternative protein source. This is a composition of chlorella. Chlorella composed some major components and lipids and fibers and proteins. Protein is the most major component in chlorella, and the content is about 60% here, like here. But however, details of component protein in chlorella remained unclear. First, we conducted electrophoresis to clarify a protein bond pattern of Chlorella pyrenoidosa, here, which is one of the major species of Chlorella. The analysis in the left panel was conducted using 12.5% acrylamide gels. The right one is with the 15% acrylamide gels. We could find some major protein bonds about 50, 25, and 12 kilodaltons. Under non-reducing conditions without 2-mel ethanol, the bonds became faint, like here. The results suggest that chlorella proteins make some SS bonds in intra and intermolecules. This slide shows the amino acid composition in Chlorella pyrenoidosa. This is cited from this papers, right here. All of amino acids in Chlorella pyrenoidosa met FAO, WHO, UN standards, like here, except leucine, here. And the essential amino acid index, which is calculated from this equation. The essential amino acid index in Chlorella pyrenoidosa was higher than soybean proteins. From this report, it is suggested that Chlorella pyrenoidosa has a superior amino acid composition compared with soy protein. It was reported that cell wall breaking treatment with dinomil improves the protein digestibility of Chlorella pyrenoidosa. However, the digestibility of Chlorella pyrenoidosa with cell wall breaking treatment have not compared with other food proteins. Thus, we conducted to compare the digestibility of Chlorella pyrenoidosa with other food proteins, soybean protein, rice and sperm protein, whey protein, and gluten. In vitro digestion test was conducted using pepsin and pancreatin to clarify the digestibility of these proteins. The pancreatin digestion for 4 hours was conducted after pepsin digestion for 2 hours. This is a result of in vitro digestion test. 0 means pre-digestion, and 2 represent 2 hours digestion with pepsin, and 4 means 2-hour digestion with pepsin followed by 2-hour digestion with pancreatin. Protein bonds in Chlorella pyrenoidosa quickly disappeared after pancreatin digestion, like here, although some protein bonds in rice and sperm here and soybean protein remained. The results suggest that Chlorella pyrenoidosa with cell wall breaking treatment has a high protein digestibility superior to soybean and rice and sperm proteins. It is known that food processing affects the digestibility of food proteins. In some food proteins, the digestibility is increased by cooking, although in some plant proteins, the digestibility is reduced by cooking. For example, it is reported that cooking makes the rice prolamine, one of the major proteins in rice and sperm, indigestible. Thus, it is very important to clarify whether cooking affects the Chlorella digestibility or not. Thus, we conducted in vitro digestion tests. The left panel represents the digestibility of Chlorella pyrenoidosa without cooking, boiling, and right one is with boiling. There are no difference between two images. Therefore, it is suggested that cooking had no effect on the digestibility of Chlorella pyrenoidosa. This is a brief summary at the first part. From these results, it is suggested that Chlorella with cell wall breaking treatment can be available as a novel alternative protein source. Then I would like to talk about the second part. The second part is the beneficial effects on Chlorella on dermatitis. The background: atopic dispositions are associated with development and severity of dermatitis. A high IgE concentration in the blood is one of the atopic dispositions. There is an interesting report relationship between atopic dermatitis and Chlorella. It was reported that Chlorella vulgaris supplementation suppressed atopic dermatitis-like symptoms and messenger RNA expression levels of interleukin-4 and interferon gamma in the body. Thus, in this study, we attempt to clarify whether Chlorella pyrenoidosa has beneficial effects on dermatitis symptoms in mice with trinitro or chlorobenzene (TNCB) application. This is a hypothesis of beneficial effects of Chlorella. First of all, Chlorella pyrenoidosa injection modifies its immune balance. For example, activation of cellular immunity and suppression of humoral immunity. After modification immune balance, the IgE production is suppressed by Chlorella pyrenoidosa injection. And finally, some dermatitis symptoms improves by Chlorella pyrenoidosa supplementation. This is an experimental procedure. We make three groups. First group is control without TNCB treatment, and the second one is with TNCB treatment, and the last one is fed 5% Chlorella pyrenoidosa powder with TNCB treatment. The TNCB treatment TNCB treatment was conducted to evoke symptoms of atopic dermatitis 3 times a week for 12 weeks. And the experimental diet were fed for 15 weeks, right here. Okay. This is a result of the contents of skin moisture. Although skin moisture was dramatically reduced by TNCB treatment here, the reduction was significantly attenuated by Chlorella pyrenoidosa injection, like here. There are typical images in each group. From this photo, we calculated the dermatitis scores based on some assessment points. This is the result. In early phase of experimental period, 3, 4, and 6 weeks, the dermatitis score was significantly suppressed by Chlorella injection. However, at the end of experiment, we could not find a significant difference between TNCB treatment groups. The next one is the result of erythema formations. Erythema is one of the typical symptoms of atopic dermatitis. Although erythema formation was also dramatically increased by TNCB treatment, Chlorella injection significantly suppressed this increment here. There are the result of concentration of the serum IgE subtypes. Unfortunately, the left one is IgG1 concentration, which is one of the indexes of humoral immunity response. Central one is represent IgG2A concentration, which is one of the indexes of cellular immunity response. The right one is a ratio of these IgG subtypes. from these results, unfortunately, we could not find any beneficial effect on the IgG subtypes of Chlorella pyrenoidosa. This is the IgE concentration of IgE in the serum. There is no significant effect between two TNCB treatment groups. And this slide shows the effect on Staphylococcus Staphylococcus aureus. It was reported that abnormality of microbiota on skin surface drastically increase, for example, drastically increase of Staphylococcus aureus populations affects the development of atopic dermatitis. Chlorella pyrenoidosa injection significantly suppressed the growth of Staphylococcus aureus on the skin surface, like here. It is a big surprise for us. The brief summary about the second part, from these results, it was suggested that Chlorella pyrenoidosa has suppressed effects on symptoms of atopic dermatitis. This is the last slide in my presentations. The conclusions. Chlorella pyrenoidosa with cell wall breaking treatment is a useful foodstuff as an alternative protein source and have a new beneficial effect, a new beneficial function on atopic dermatitis. So, thank you for your kind attention.
Okay, thank you. So, any comment from Roma? Okay.
Hi, nice talk. Your first conclusion, right, that it can be used as an alternative protein source. When you extract it, is the protein still green? And if so, what are the applications in food? I mean, is it quite limited? Because again, I'm from Singapore Institute of Food Biotechnology Innovations. My name is Sumanta Haldar, and we are also looking at Chlorella as a microalgae and also some macroalgae as well. And we are actually trying to separate out, but what we found actually is that, of course, even when you extract the protein, it still remains green. So we've not been able to remove that green color. What's your thoughts and comments?
Okay, thank you very much. Nice questions. And Professor Masumura, he's a co-researcher with us. He reported interesting preliminary data that the protein bound in Chlorella has almost the same molecular size compared with chloroplast in the Adoptotes. Maybe the main component proteins related to chloroplast because it is hard to separate the green colors. I think yes.